Very warm greetings, my dear friends. In this video, we are studying about derivative using differentiation rules. Suppose we have the function y equal to fx, then we can find out the derivative of this f of x using the definition or using the limit concept. In the earlier videos, we studied this. Hereafter, we have to remember the derivative of the standard function and some derivative rules. Using this, we can find out the derivative of the given function easily. Suppose we have the function y equal to fx. So y is a function in x, y involving the variable x. It may be x square or x square plus 5 plus 2x or sin x or tan x, like that. So y is a function involving x. The derivative of y is denoted by y dash. Derivative of y. It is denoted by y dash. Or here f of x is a function, no? So f dash of x. Y dash we can write, or f dash of x we can write. Because here the function is involving x, so we can write derivative of y, it is by dy over dx, dy by dx. Derivative of y with respect to x. Y is a function, so what is the meaning of this? Derivative of y with respect to x. Y with respect to x here, the function is a variable in x. So y dash we can write, or f dash of x we can write, or dy by dx. Any one of these notation we can follow for the derivative of y equal to fx. So now I am giving the standard rules or derivative of basic functions. Let us assume these are rules. So using these rules, we can find out easily the derivative of a function. So compare with limit concept or derivative using definition. If you know this derivative rules, then easily we can find out the derivative of any function. I'm giving here the rules table. Consider this table. I'm giving here three columns. So here in second column, I'm giving the value of y. Y equal to some function in x. And here I am giving corresponding derivative. Corresponding derivative we can denote either by y dash or dy by dx. Suppose y is a constant, y equal to 10 or y equal to 20.5 or y equal to 30 by 11, 22 by 7, any value. So any constant if we have, then the corresponding derivative it is 0. How we are finding this value means using the definition of derivative limit concept. We have the derivative formula, limit h tends to 0, f of x plus h minus f of x divided by h. So using that rule only, we have to get this all the rules. Okay, but hereafter you have to take this as a rule and we have to find out the derivative of other function. Suppose y equal to x power n. What is the derivative here? N time x power n minus 1. So easily we can remember x power n derivative. This n we have to write here. And here in power I am taking minus 1. So n time x power n minus 1. Here x is the variable, n is the number. But next one you have to see a power x. A is a constant number. Power x. Suppose 10 power x. 3 power x. Like that. So what is the derivative of a power x? We have a power x time log a. This ln mean natural logarithm. E power x derivative e power x itself. E power minus x derivative minus e power minus x. Root x derivative 1 by 2 root x. Then natural logarithm. Log x derivative 1 by x. So everything you have to remember. So like that I will continue the table. Continue the table. Here you have to see. Previously we are having natural logarithm. Now here log x to the base a. What is the derivative of this function? 1 divided by x log a. Log is here ln. Ln means natural logarithm. Sin x. If y equal to sin x, what is y dash? Cosine x. If y equal to cosine x, what is the derivative? Minus sin x. Y equal to tan x derivative, y dash equal to sec square x, or tan x derivative is sec square x. Similarly, cot x derivative minus cosec square x, sec x derivative sec x tan x, cosec x derivative minus cosec x cot x. Now we have inverse sine function, sine inverse of x. Sine inverse of x derivative is 1 by square root of 1 minus x square. Cosine inverse x derivative minus 1 by square root of 1 minus x square. Easily we can remember. Tan inverse x derivative 1 by 1 plus x square. Cot inverse derivative minus 1 by 1 plus x square. Sec inverse derivative 1 by modulus of x square root of x square minus 1. Cosec inverse derivative minus 1 by modulus of x square root of x square minus 1. Now we have the basic properties or basic rules. Derivative of d by dx of k time f of x. F of x is a given function. We are finding d by dx, derivative of k time f of x. So what is the derivative of this, which is equal to this k? I have to take in front. So k is a constant. So constant, keep it. And only the function you have to find out the derivative. So if how we are finding derivative of d by dx mean derivative. Derivative of fx plus gx mean this fx we can find out the derivative, and gx you can find out the derivative, take sum. Similarly for subtraction, derivative of f of x minus g of x mean f of x you have to find out the derivative, g of x we can find out the derivative, take subtraction. So this is also the notation for derivative I told you, dash. So u is a function in x, v is another function in x. U times v, then we are finding the derivative. So derivative of product of two function. One function is u, another function is v. So derivative of product of two function. So u times v derivative equal to, how we are finding this? Carefully remember important rule. I'm keeping u, finding the derivative of v. So u same thing, v derivative is v dash. Then plus other function, keep v and derivative of u, it is u dash. So u v dash plus v u dash. Easily we can remember this. Same idea, now derivative of u by v. So u is one function in x, v is another function in x. So we can find out the quotient u by v, derivative of quotient function. So what we are having, in the denominator you have to see here v square. What is here? V, here v square. Easily we can remember. Then this v, first you have to keep. Denominator you have to keep it. Numerator derivative u dash. V u dash minus u v dash. Okay. So these are the important rules. Very much important. Okay. Consider the problem. Find the derivative of a function fx equal to 5x cube minus x plus 1. So what is given to you? Fx equal to 5x cube minus x plus 1. So x means x power 1. Remember this. So derivative of f of x, it is denoted by f dash of x. Here f of x is given, so derivative is f dash of x. How we are finding this? This 5 is the constant. I am keeping 5. Multiply x power n derivative we know. X power n derivatives n time x power n minus 1. So here x power 3 derivative, x cube derivatives 3 times x power 3 minus 1, it is 2. Okay, so 5x cube derivative completed. Then minus, here minus available, so minus x power 1 derivative. So n, in place of n we have 1. So x power 1 derivative 1 time x power 1 minus 1. So I can write 1 time x power 1 minus 1 is 0. Then 1 is the number, constant derivative, first formula, it is 0. Now we can calculate this. 5 times 3 is 15 x square minus 1, x power 0 is 1. So 1 plus 0, no need to write. So remember this hereafter. This 5x cube derivative, easily we can write this 5 and this 3 and 5 we can multiply. So 15 x power, what is the number here? 3 minus 1, 2 we can write. So no need to write step by step. That directly you can write 3 times 5 is 15, like that. And here what is the power? Subtract by 1. And remember derivative of x is 1. No need to write 1 time x power 0 like that. So directly you can remember derivative of x is 1. Okay. Friends, consider this problem. Find the derivative of fx equal to 8 times x power 4 plus 9 times x square minus 1. So fx equal to 8 times x power 4 plus 9 times x square minus 1. Derivative of f of x is denoted by f dash of x, which is equal to, already I told you, try to write directly. This 4 and 8 multiply and write here. So 4 times 8 is 32. X power, here already 4 is available. So 4 minus 1, 3. So first term derivative completed. Now second term. So here plus, same idea. 2 and 9 I can multiply. So 2 times 9 is 18. X power 2 minus 1, it is 1. X power 1 is x. Then minus 1 derivative 0. So no need to write that. This is our answer. Let us consider this problem. Find the derivative of fx equal to x square times 2 by x square plus 5 by x cube. How we are doing this problem? Easily. First I am writing what is a given function. Fx equal to x square times 2 by x square plus 5 by x cube. So in denominator we have any function, means u by v rule we can try. Or is it possible to take it into numerator? Then it's also okay. But here outside 1x square is available. I have to multiply inside easily. What I have here, x square times 2 by x square. Then x square times 5 by x cube equal to, I have to see here, this x square in numerator, x square in denominator will be deleted, remaining 2. Then plus, here 5 is the number, I am writing 5. Here x square I can delete. Here x power 3 available, 2x will be deleted, remaining 1x will be available. So remaining x power 1, it is our x. So 5 by x. And which is equal to, here 2 plus 5 by x mean 5, x power minus 1. Okay, so this is our fx. Still we are not finding derivative. So now we can find out the derivative is f dash of x equal to, what is the derivative of 2? It is 0 because it is a constant. And here already I told you 5x power minus 1. This minus 1 multiply with 5. It is minus 5 x power, already minus 1 available, then subtract by minus 1. So we have minus 2. So 0 no need to write, minus 5 divided by x power minus 2 right in the denominator, x square. So this is our f dash of x. Consider this problem. Find the derivative of fx equal to x plus 2 times 2x square minus 3. This problem we can try in two ways. First, to simplify this function f of x, then get one polynomial, then take directly derivative of the polynomial. That is one way. And another way is, here it is a product of two functions. First one is we have to take u, and the second function is v. So product of two functions. So we can use the product rule. Okay, so now I am using the product. So what is f of x here? F of x equal to x plus 2 multiply 2x square minus 3. Recall the rule, u times v derivative equal to u derivative of v, then plus v derivative of u. Same idea here. So I am finding derivative of f of x. It is f dash of x. By the rule, here u is x plus 2. This is our v. V is 2x square minus 3. So I can use this formula. So I can take x plus 2 and derivative of v. I am writing 2x square minus 3 derivative. I am writing like this easily. Then plus v is 2x square minus 3 times derivative of u is x plus 2, derivative I am writing dash, which is equal to, now easily we can find out. First bracket the same thing, x plus 2, derivative of this expression 2x square minus 3, easily we can find out, simple. So 2 times 2 it is 4, x power 2 minus 1 it is x. Minus 3 is a constant derivative is 0, so no need to write that, so only 4x. So this first term finished. Now second term first expression is 2x square minus 3, then this second term x plus 2 derivative, x derivative already I told you it is 1, 2 derivative, 2 is a constant, derivative is 0, no need to write, which is equal to, just to multiply this, 4x multiply x, so it is 4x square, then plus 4x times 2, it is 8x. Here you have to see 2x square minus 3 multiply 1, so plus 2x square minus 3. Simplify this, 4x square plus 2x square, it is 6x square, then plus 8x minus 3. Friends, here we have to consider the problem, find the derivative of fx equal to sin x times tan x. So here also product of two functions. One function we have to consider as u, another function is v. So what is the rule we are using? U times v for this function derivative. What is the rule we have? We have to recall the rule, u derivative of v plus v derivative of u. So the same concept I am using here. So what is the given function? Fx. Always we are starting with the given function. Fx equal to sin x times tan x. What is the derivative of fx? It is f dash of x equal to keep sin x times tan x derivative. One function you can keep another function derivative. Then plus another function we can keep tan x, the first function derivative, sin x derivative, equal to, recall the formula, sin x is same sin x here, tan x derivative is 6 square x, then plus tan x I can keep, sin x derivative is cosine x. Now is it possible to simplify? We can simplify. First term sin x times 6 square x plus tan x times cosine x. Tan x I can write sin x by cosine x. Tan x, basic idea. Tan x equal to sin x by cosine x. Multiply this cosine x. You have to see this cosine x, numerator, denominator cosine x will be deleted. What is remaining? Sin x 6 square x plus sin x. So what is the common term here? Sin x is available in both the term. I can take sin x outside. Remaining is 6 square x plus 1. Again we have same type of product rule here. So find the derivative of fx equal to 3x power 5 cot inverse x. Here also product rule we can use. What is fx? Fx equal to 3x power 5 cot inverse x. We can find out f dash of x using product rule. Here 3x power 5 is our u, cot inverse x is our v. So one function, first function I can keep it, second function we can find out the derivative, cot inverse x derivative. Then plus second function I can keep cot inverse x, then derivative of first function 3x power 5 derivative equal to 3x power 5 cot inverse x derivative minus 1 divided by 1 plus x square, then plus here cot inverse x. What is derivative of 3x power 5? It is 15x power 4. Just simplify this, which is equal to minus 3x power 5 divided by 1 plus x square plus 15x power 4 times cot inverse x. Consider the problem here. Find the derivative of fx equal to x cube plus 2x square minus 4 over 3. So it is looking like quotient rule, u by v derivative. But in the denominator we have the constant 3. So no need to apply quotient rule. Directly we can use the rule. Okay, so what is fx? Fx equal to x cube plus 2x square minus 4 over 3. Same fx again I can rewrite like this. 1 by 3 multiplying x power 3, x cube plus 2x square minus 4. So it is looking like some constant times fx. So now we can find out the derivative easily. F dash of x equal to constant time fx means the derivative constant you can keep it. Only the function fx derivative we can find out. So 1 by 3 multiply this x cube derivative. X cube derivative is 3x square. Then plus 2x square derivative. 2x square derivative is 4x minus 4 derivative 0. Here we have the problem. Find the derivative of f of x equal to 4x cube minus 2x plus 1 over x square. Here two ways we can do this problem. One way is just to simplify f of x. Divide the numerator by denominator first, then we can find out the derivative, or we can use the quotient rule. U by v derivative, we have the rule. Okay, so now I am using quotient rule. So let us take this numerator is u, denominator is v. What is the rule we are having? Quotient rule, derivative of u by v equal to denominator is v square. Here we can keep v, derivative of u, then minus keep u, derivative of v. This is a rule. So using this rule easily we can do it. What is a given function? Fx equal to 4x cubed minus 2x plus 1 by x square. So what is f dash of x? Equal to, using the quotient rule, big line, this x square, this is our v, but in the rule you have to see it is v square, so x square or this square. Now keep v, that is our x square, time u derivative, u is 4x cubed minus 2x plus 1 derivative, then minus 4x cubed minus 2x plus 1 time denominator derivative, x square derivative. Just to take the derivative of the function, we can do it. Denominator is x power 4. Here you have to see x square. Derivative of 4x cube. It is 4 times 3, 12 x square. Minus 2, derivative of x is 1. So 2. Then plus 1 derivative 0. Minus 4x cube minus 2x plus 1 time x square derivative, it is 2x. Now only simplification. Here x power 4. Just to multiply inside x square time 12x square, it is 12x power 4. X square time minus 2, it is minus 2x square. Here you have to see minus 2x multiply 4x cubed. So minus 8x power 4. Minus 2x multiply minus 2x. So plus 4x square. Minus 2x multiply 1. So minus 2x. Next to simplify this. Denominator is x power 4. 12x power 4 minus 8x power 4. It is 4x power 4. Then x square term you have to see plus 4x square minus 2x square. So plus 2x square. Then minus 2x. So what is the common term here? We can take it outside. X is common, 2 is common. So 2x I can take outside. Remaining is here 2x power 3. Then plus here x. Here minus 1. By x power 4. 1x I can delete. So remaining we can write 2 times 2x cube plus x minus 1 by x power 3. Okay. Again we have the problem using quotient rule. Find the derivative of fx equal to x plus 9 over x square minus 7x plus 1. So what is a given function? Fx we can write. Fx equal to x plus 9 over x square minus 7x plus 1. Using the quotient rule, f dash of x equal to denominator, first I am writing x square minus 7x plus 1 square using the quotient rule. Again write the denominator here, x square minus 7x plus 1 times numerator derivative, x plus 9 derivative. then minus numerator I can keep x plus 9 derivative of the denominator x square minus 7x plus 1 derivative. Now easily we can find out the derivative. X square minus 7x plus 1 the whole square in denominator. Here numerator you have to see x square minus 7x plus 1 time x plus 9 derivative. X derivative is 1, 9 derivative is 0, so 1 minus x plus 9 times x square minus 7x plus 1 derivative. X square derivative 2x minus 7x derivative. 7 is the number, x derivative 1. So minus 7, then plus 1 derivative 0. So no need to write 0. Now just to multiply, enumerate. 1 time x square minus 7x plus 1. So it is x square minus 7x plus 1. Now multiply the second term. Minus x multiply with this. Here minus x multiply with 2x minus 7. So minus x multiply 2x is minus 2x square. Minus x multiply minus 7. It is plus 7x. Next, this 9 and this minus outside. So minus 9 times 2x is minus 18x. Minus 9 times minus 7. It is plus 63. Over denominator no change. X square minus 7x plus 1 square. Then simplify the above expression what we have. So left side we have f dash of x equal to minus x square minus 18x plus 64 over the denominator is x square minus 7x plus 1 square. Again we have the problem using quotient rule. Find the derivative of fx, which is equal to 1 plus cosine x over 1 minus cosine x. So what is fx? Equal to 1 plus cosine x over 1 minus cosine x. So now I can use the quotient rule. F dash of x equal to denominator is 1 minus cosine x square. And here keep denominator 1 minus cosine x time 1 plus cosine x derivative. Then minus keep 1 plus cosine x and the derivative of denominator 1 minus cosine x derivative equal to denominator is 1 minus cosine x square. Numerator 1 minus cosine x time 1 plus cosine x derivative. 1 derivative is 0, no need to write. Cosine x derivative is minus sine x. Next minus 1 plus cosine x time 1 minus cosine x derivative. 1 derivative is 0, minus cosine x derivative is sine x. Sine x derivative minus sine x. So minus cosine x derivative sine x. Now just to simplify this. What is the numerator? 1 time minus sine x. Just to multiply this, minus sine x, then minus cosine x time minus sine x, minus time minus plus cosine x multiply sine x. Now the second one, sine x multiply this. Outside we have minus, so minus 1 time sine x minus sine x. Cosine x times sine x, outside minus, so minus cosine x times sine x over 1 minus cosine x square. Which term will be deleted here? Cosine x times sine x plus, and here minus cosine x sine x. So it will be deleted. So remaining is here 1 minus sine x, here again minus sine x. So minus 2 times sine x over 1 minus cosine x square. So we have the problem. Find the derivative of fx equal to tan x over 1 minus sec x. So again we have to use quotient rule. So what is fx here? Fx equal to tan x over 1 minus sec x. Derivative of fx, f dash of x equal to, I am using the quotient rule. Denominator is 1 minus sec x square. Numerator is, I keep the denominator here, 1 minus sec x multiply derivative of the numerator, tan x dash, minus keep tan x, derivative of 1 minus sec x. Now we can find the derivative. Denominator is same, 1 minus sec x square. Numerator is 1 minus sec x. What is tan x derivative? Sec square x minus here tan x. What is 1 minus sec x derivative? 1 derivative 0, no need to write. Minus sec x derivative sec x tan x. So equal to same denominator 1 minus sec x square. Numerator, just to simplify, 1 multiply sec square x. It is sec square x. Then minus sec cube x. Here minus time minus plus sec x time tan square x. So f dash of x equal to, so in the numerator sec x is common, available in all the term. So sec x time remaining is sec x minus sec square x plus tan square x over 1 minus sec x square. which is equal to, here sec x time, here sec x, what is sec square x plus tan square x, which is equal to minus 1 divided by 1 minus sec x square. What you have to remember here, this rule we have already, 1 plus tan square x equal to sec square x. So from this, sec square x come to this side, minus sec square x. Then this 1 I am taking other side. So here remaining is tan square x, 1 right other side, minus 1. So using this concept, I am writing minus sec square x plus tan square x equal to minus 1. This value become minus 1. Okay. So here sec x minus 1, I can write this by, I am taking minus outside, minus sec x multiply with this minus 1 become plus 1, this plus sec x become minus sec x over 1 minus sec x square. Okay, so 1 minus sec x, 1 minus sec x will be deleted. So remaining is minus sec x over 1 minus sec x. Again we have the problem using the quotient rule. Find the derivative of fx equal to log x to the base 2 over cos inverse x or cosine inverse x. So fx equal to log x to the base 2 over cosine inverse x. So log x to the base 2 is our u and v is cosine inverse x. So we have to apply the quotient rule. F dash of x equal to, first I am writing the denominator cosine inverse x square. Here I can write the denominator cosine inverse x multiply derivative of the numerator log x to the base 2 derivative, then minus numerator log x to the base 2 times derivative of the denominator cosine inverse x denominator derivative. So now we can use the rule. If you have to see the table, we can get easily. Cosine inverse x, same cosine inverse x. Log x to the base a, you have to recall the derivative of log x to the base a, derivative. Okay, what is the derivative I'm giving to you? It is 1 by x log a. Okay, so in place of a, here we have, so log x to the base 2 derivative 1 by x time natural logarithm log 2. Then here minus log x to the base 2 cosine inverse x derivative minus 1 divided by root of 1 minus x square over cosine inverse x square. Just to simplify, just to multiply this and to multiply this. What we have, f dash of x equal to cosine inverse x over x log 2, then plus log x to the base 2 over square root of 1 minus x square divided by cosine inverse x square. Thank you for watching this video.